And the next one is Design X for consumer products. So for this one, we have many examples where we have used these types of scanners to capture devices, products, and consumer products in design here. So for today's example, if you use all these different kinds of scanners, and there are hundreds and hundreds of them out there that can scan these types of objects, you can bring in that information from whatever scanner that you've used here, and you can reverse engineer based off of that information. So with this example, I think what makes it a little special and different from just your vanilla reverse engineering example that I presented on that very first slide where you scan, you model, and then you send it to CAD, is with these types of instruments here, like a guitar, many times these instruments were created by hand, and there's lots of examples in the market out there where there's handmade devices that are highly tuned and highly special that have a certain shape, that create a certain sound, right? And they were designed by a very special person even, right? Like it was somebody that was a famous guitar maker, and that exact shape or size is very particular, right? So these examples here of scanning these instruments, the majority of the time, it's the companies themselves. So Fender or Gibson or Martin, they actually will take their own designs from the early 1900s and 3D scan them and bring in their designs, and it allows them to analyze what was done that makes that specific special design. Sometimes it's the materials as well. Also preserve those designs, right? So if anything were ever to happen to that specific instrument, they have a scan of it, and they can use software like ours to then reproduce that object, right? So this allows you to use Design X with all of our feature recognition, our loft and crazy shape extraction tools, and drawing surfaces right on the surface of the part. And use your accuracy analyzer and all those things to be able to create a very accurate representation of what was modeled in the past. So for this example, I'll go ahead and load up a model that we have, and we'll just toggle back over here again. Thank you for bearing with me with the screen changes. As this series goes along, I'll probably get a little bit better at it, make it a little faster. So here we'll hide the whole thing, and we'll just show the scan for the moment. So here's an example of a 3D scan of a Telecaster, right, of Tele. And this is a great one just to kind of show, because it's a pretty basic example here, but you can see here that the neck is not very basic, but you can model the basic shape of this object very quickly here. And I have it separated out into two pieces, right? So here's the body, and then here's the neck. And this brings up a good point, that you could scan the body and model. So if there's different neck joints, you could retrofit another design to fit this type of body. So not always are you reverse engineering the object you scanned. Sometimes you use the scanned object to design something around it, which is an example of what this would be if I was going to redesign that neck there. But you see here with Design X, I'm just going to roll back. If you've been given a Design X file that has everything in it, this is an extremely powerful feature here, because we're a history-based modeler, and you can take a look at how the person modeled this object step by step and learn how they modeled it from the history tree. So you see here, the first step is they drew this sketch. And if I just go normal to hide the mesh there, you see that they created that sketch. And then the next step is if you just roll forward that they extruded that. And we'll just turn on there we go. Turn on the solid of the extrude there. And here's the other thing that's interesting. At any moment, even while we have this part loaded up, we can stop and check the deviation. So you can see the top of that surface. The bottom is a little wavy. You see there's lots of sanding going on, or maybe this thing was used for many, many years. But you get feedback to know how close you're following that mesh using the deviation, the accuracy analyzer. So from here, you can just kind of scroll forward and see, okay, now they applied the fillets to that. Then the next two steps is they cut the pocket for the neck. Then they went ahead and filleted the joints there. They cut the two different pockets for the pickups, created your fillets there. And you see how you're able to rewind and look back through the history and kind of learn what it is that everyone did along the way. And you can see how this is extremely valuable. While this is a simple example where they were able to fit, there's where the plug goes in for the controls, and then imported the neck to make sure that that fits there. And then, of course, turn that on. And then the final result, you can check the accuracy analyzer to see how close it was modeled. And again, you can also tweak this too if you want to change the range of the accuracy analyzer as well. Now, one of the other most valuable features here for Design X is not the fact that we created a Design X model of this part from scan data. While all those tools are amazing, but that final step is that you can take this and send this over to CAD and send it over to specific CAD package. So in this instance here, I can actually load up SolidWorks, and we'll just toggle over to SolidWorks. And you'll see here that we sent this over. Now I'm going to go ahead and just close that, and we'll take Design X. And while SolidWorks is showing, I'm going to, on my other monitor, send over the part. So you can see here that I went ahead and cleared out that part and then hit send with the live transfer tool in Design X. And you see what it's doing, it's building it line by line over inside of SolidWorks as native entities. So you see all of the features, constraints, sketches, relations, all of those things are coming across as native entities inside of SolidWorks, allowing you to then give this part. So if you were able to give this part to another person on your team that was then going to go CNC mill it or whatever, you would be able to hand this over to them, save the part out, and they'll be able to pick up right from there. They don't have to have any special software. They're just going to load up the SolidWorks part. Or you could actually just save this out as a step. I just sat neutral, all those different formats as well. A lot of people, that's all they need as well. And you can bring that inside of your CAD package or CNC or CAM package and work with it from there. So you see here, we just did a live transfer here on the webinar of how you can send that over into SolidWorks from Design X.